Welcome to Study Loop.
So the question is why radius of zirconium and hafnium are nearly identical. As we know that zirconium belongs to the 4D series, and this hafnium belongs to the 5D series, and this belongs to the fifth period zirconium, and this belongs to the sixth period hafnium, and this is belongs to the second transition series element, and this is belongs to the third transition series element. So third transition series element. So now the question is why their radius are nearly identical. Their radius are nearly identical or same in size. So this is the reason due to lengthenoid contraction. So due to the lengthenoid contraction lengthenoid contraction So due to the lengthenoid contraction, so their radius is almost nearly identical. So lengthenoid contraction is nothing but the gradual decrease in the atomic or ionic radii with increase in the atomic number. That is called the lengthenoid contraction. As we see that when you go from zirconium to hafnium, as down the group, the shell is added, and shell is increased, and radius is automatically increased. But this is not actually happening. The other thing is that there is, but due to poor shielding, due to the poor shielding effect of f electron, poor shielding effect of f electrons, z effective increase. So increase z effective increase. So radius is decrease. As we know, when you go from zirconium to hafnium, a radius is increase, like radius will increase, and here due to the poor shielding effect of the f electron, so radius will decrease. So ultimately what is going to happening, the radius is almost identical. So radius is almost we can say the identical. That means that is not much increase. As we know that the if we compare the screening power also, like for s greater than p, d and f, for the f orbital, so this is the poor screening poor screening. So due to the poor screening, if we add a diagram for this, so this is our nucleus, and this is the 4f orbital, this is 6s. So this f orbital are the poor screen. So this is the poor poor screening or shielding, both are the same term. Poor screening, or you can say shielding. So you can say poor screening or poor shielding. So here poor screening or shielding, so both are the same term. So this outermost electron, so this what is going to happening there, increase the z effective. So due to the poor screening of f electron, z effective, so z effective is the effective nuclear charge on outer electron. So on the outer electron increase. Why? Because here it is a not much screen these outer electron, so as a result radius will decrease. So radius will decrease, and in this case radius is almost the identical for the case of zirconium and hafnium. But when we comparison from 3D to 4D series, radius will increase. 3D to 4D radius will increase, but 4D to 5D series, 5D series, as we move, as we move, it almost, or you can say it almost, radii radii are same radii are same due to poor screening of f electron, due to the poor screening of f electrons. So this is the reason why, this is the reason why zirconium and hafnium are nearly identical size. So due to the we can say lengthenoid contraction is applicable in this case. So lengthenoid contraction is the gradual decrease in the atomic or ionic radii with increase in atomic number, and in this case one factor increase as we move down the group, shell is added, so radius increase, but screening of half electron, radius is almost decrease. So one factor increase the radius, other is decrease the radius, so radius is almost nearly identical in this case. So due to the lengthened contraction, their radius is identical.